وعليكم السلام. Okay, let me start our teaching today with an example. We have talked about neural network in the past lectures, and we said what is neural network, but I think it's better to repeat some points in neural network. I start with a simple example. Assume that you have a system with two inputs and one output. Again, we have a system with two inputs and one output. The inputs are x1 and x2, and output is f. And what's the problem? We want to find what is the relation between f, x1 and x2. Again, you can see this. We have system here. In the system, we have x1, x2 as input and f as output. And we have some examples of input and output. We know that if the inputs x1 is 3 and x2 is 5, then the output is 1.1. This is something that we set in the system. We have 5 examples here, 5 samples in the system. And the question is that we want to find a map from x1, x2 to f. This is the problem that we want to solve today. The problem of estimating a function. You want to estimate a function. You want to find a function. Yes, the topic is related to neural network. Okay, because I see that you have some problems with neural network and you asked me about neural network, so I want to make it easier. Okay, this is related to neural network. Now, see the question again. We have some inputs and we can say we have some inputs and outputs. We want to find which function is in the box. We want to find which function is in the box. One of the classical form for finding the function between input and outputs is to guess the function. We guess a function for this. For example, we say that f is, or the output is, a linear function of input. What is the meaning of linear function? It means that f is equal to a number coefficient first input and another coefficient multiply the second input. We guess that. We assume that the output is a function of a linear function of inputs. It means that f is w1 in x1 plus w2 in x2. We assume that f is this. And now the problem will change. The problem will change to a simpler problem. Now we just need to find w1 and w2. We just need to find w1 and w2. See this slide. This is our table. We want to find w1 and w2. We want to find w1 and w2 such that 3 in w1 plus 5 in w2. 3 in w1 plus 5 in w2 be as close as possible to 1.1. We want to find w1 and w2 such that, for example, w1 multiply in 2 plus w2 multiply in 5. w1 multiply in 2 plus w2 multiply in 5 be as close as possible to minus 1.1. This is the problem that you want to solve. So let me repeat this again. I want to find a function between inputs and output. In order to find this, at first I guess a function, a linear function. This linear function has two unknown parameters, w1 and w2. And so the question will be changed to finding these two parameters. If you want to ask a question, please type faster. Okay. Now we define error formula. What is the meaning of this error? What is the meaning of this error here? If you have a look, I said that I want to find W and W2 such that 5 in W2 be close to 1.1. In order to have this, I say that I have to minimize this. Have a look in this formula. Please have a look in this formula. In this formula, if we minimize the error, if we minimize this relation, we name this MSE. If we minimize MSE, what will happen? If we minimize this, it means that 4 in W1 plus 3 in W2, for example, is close to 4.3. And what does it mean again? It means that 3 in W1 plus 5 in W2 is close to 1.1. In other words, if we minimize this error, we have this. If we minimize this error, we can say that 3 in W1 plus 5 in W2 is close to 1.1. What is the ideal form? The ideal is that give us a specific law because we feel that we are in its perpetuity. What do you mean by a specific law? We will talk about this Yasser Salam Jassim Al-Tamimi, but about the question about 1/5 for what? 1/5, I say 1/5? No. This is, oh, yes. This is the definition of mean square error. Let me, I'll talk about this. This is 1/5, yes. This to have an average on the error. I'll talk about this. Have a look here, please. Have a look here. What is the meaning of this, for example? What is the meaning of this? This term, 2 in W1 plus 2 in W2 minus 1.9 with the power of 2. The power is error. We need to minimize all these terms. We have 5 terms. Each term is related to a row of the table. We want to minimize all these 5. Okay? For example, if I minimize this one, it means that in this row I have made 4 in W1 plus 3 in W2 close to 4.8. Okay, in summation, if I want to give you if we want to give a point, if I minimize this error as possible as as I can say that I have find the correct W1 and W2. Okay, in ideal form, in very ideal form, when MSE is 0, what does it mean? If MSE is 0, if I can find W1 and W2 such that I have MSE 0, it means that this term is 0, and this is 0, and this is 0, and this is 0. This all these 5 terms are 0. And what does it mean? It means that 2 in W1 plus 5 is W2 is exactly minus 1.1. And 2 in W1 plus 2 in W2 is exactly 1.9. And what is the advantage of this 1/5 that you asked? What is the advantage of this? In this problem, no difference. You can remove this. In this problem, you can even remove this. No difference. If you minimize this, error, or minimize this without with 1/5, because there is no difference. If I minimize a term, I have minimized 1/5 of that. Okay, but this is the standard formula. This definition is standard. Mean square error is the average. Mean means average. The average of a square error. This is a square error. If every term is a square error, this is the average. Because we have 5 rows, we use 1/5. Okay, this is just averaging on the errors. We have also another error function here. Mean absolute error. This is my mistake. Like this. The name is mean absolute error. Okay, now we have another error function, which is mean absolute error. Mean absolute error is the average of the difference between the output and the desired output. When I say output, it means, for example, here it means 2 in, excuse me, when I say output, here I mean, for example, in the sorry, I have a problem with my pen. Again, when I say output, it means that, for example, 2 in W1 plus 5 in W2. And when I say the desired output, it means minus 1.1. But you ask why we did it power 2 from the low. This is just definition. Have a look here. We have some measures for error. We have some measures. I said that MSE is the summation of output minus desired output power 2. This is MSE. But MAE is the average of the absolute. This is absolute. I think in Arabic it is qadr mutlaq. And why we use absolute or power 2? Why we use one of these two? Do you know why we use absolute value or a square? Because you know why do you use? To have positive values. In order to have positive values. Okay? We want to have positive values because we have a summation between these errors. We have some summation between here we have a summation, and this is the error, for example, for row 3. This is the error for row number 2. This is the error for row number 5. And we want to have a summation on all errors. Okay, so, and of course for the mean square error, we want to have a summation or errors of different rows, so we have to make all these positive numbers. So, if I want to have a conclusion on this page, this is part of my presentation. The problem here is to find W1 and W2 such that we can have this, we can minimize this. By minimizing this formula, we can have, we can find W1 and W2. But how do you solve this equation? How do you minimize this? How can you minimize? For example, how do you minimize this? 3x1 plus 2x2 minus 5 plus 1x1 plus 3x2 minus 7 plus. How do you solve this? How do you minimize this? Do the power and find x1 by x. Huh? Can one of you solve this? For example, in this, we can't make all this zero. If we can, it's let me. I can say W2 minus 1.1 4W1 plus 2W2 minus 6.2 is 0. 4W1 plus 3W2 minus 4.3 is 0. And you mean this? Can you solve this? You have 5 equation and you have 2 variables. You can't solve this. Okay, we can't solve this problem by this formula. This is not a solution because this is not exactly zero. This is close to zero. If we are sure that these are exactly zero, we can solve this the first two. I solve just the first two, and I say that this is or any. It is enough to just two of these equations, and I can solve the problem. But this is not exactly zero. This is close to zero. I want to find W1 and W2 to have this as close as possible to zero. I'm not sure. This is not true that these are R0. Okay, in ideal form, all of these are zero, and we can say this. In order to solve this problem, we have some solutions. One of the most famous is to make differentiation on this formula. We say that round of error over round of W1 is 0 and round of error on round of W2 is 0, and this gives me an equation, and also it gives me an equation, and by solving this equation we can find W1 and W2. This is a classical and a normal solution for the problem. How do we minimize a function? You minimize function by making a differential on the function mushtaq. By making mushtaq function, you can solve the problem. But here, this is not the thing that we want to do, because for some function, it is very difficult to make mushtaq. Of course, here it is easy to do your differentiation, but generally it is not easy to do this. It is not easy. There is another formula, another solution for this problem, which is known as GS, or gradient distance. Gradient distance, let me find the word in Arabic. In Arabic, in Wikipedia, you can see this. This is Kharaz. Miyata Aslat Tadraj. I sent the link to you. This is the Arabic name of the method that I want to talk about is. But in English, this is gradient distance. Gradient descents. But what is this method, gradient descents? What is gradient distance, or the Arabic name خارج متر أصل تدرج. This is the thing that I sent you in the video. Gradient distance or statistical gradient distance, we change W's, we change this W by adding a value, value. The value is alpha EI XI. What is alpha? Alpha is a number between 0 and 1. And what's EI? EI is error of one input. It means that excuse me, where did this go? Error here, this is error. Error is the difference between output and the desired output. And XI is the input. For example, if we go to our own example here, let me go to our example. We want to find W1 and W1 and W2. In gradient descent method, at first we guess two values for W's, for two W's. For example, we assume that W1 is 1 and W2 is 1. This is just a start point. We use start from 1 and 1. And gradient descent says that modify the weight by using this formula. W1 is W1 plus alpha E X. What does it mean? I use W1 and WI, I say. This I is 1 or 2 in our problem. What does it mean? It means that, for example, in the first row, if I use 3, 5 as input, out is 3 in 1 plus 5 in 1. This is 8. And what is error here? Or I? Error here is F minus out. This is 1.5 minus 8, which is 6.9. Okay. In the gradient distance, we calculate error. It is very simple. Error is calculating by calculating the output and calculating difference between outputs and the desired output. I want to have 1.1, but here I get 8. So I have error. Gradient descent says that if you want to modify W, you have to use this formula. Have a multiplication between alpha. Here we assume that alpha is, for example, 1.1, 0.1. This is 0.1 in EI, which is minus 6.9, and XI, here X1 is 3 and X2 is 5. For example, here, if I want to calculate W1, I say that W1 is W1 plus alpha. I said we use 0.1. EI is minus 6.9, and XI here is 3. This is 1 plus, if I multiply this is 3 in 69, this is 1.97, and this is 3. So what did I do? I have modified the weight. I have modified the weight by a formula. Which formula? I said that W1 can be modified by this formula. W1 is W1 plus alpha EI XI. Alpha is a fixed number between 0 and 1. We have chosen 0.1. EI is the error of the output if I use 1 and 1, and the desired output if I use 1 and 1 in this system. With the input 3, 5, we will get 8. So the error is 8, the difference between 8 and 1.1, and this is minus 6.9. So I modify the W1. I do the same for W2. W2 is W2 plus 0.1 in, the error is minus 6.9. And XI here is 5. If I calculate this, I can, excuse me. What was this? It was 2.97. And here this is 5 is 69. Okay, gradient distance says that you can receive from 1 to 2.97 and 4.45. And if we repeat this, we can receive the 2 W1 and W2 of our problem. The best, we can find the best W1 and W2 of problem. I have tested this. I have tested this on numbers. This is easy. I did this in an Excel 5. Excuse me. Have a look here. Here, this is x1. Let me change the name. x2 and f. See this in see the problem again. We have x1, x2 as input and f as output. And this is the numbers in these are numbers in these are the numbers in my Excel. Give me time to find a better Okay, are you in class? If you are here, please answer me to be sure. Do you follow me? Okay, thank you. Thank you. Here, I just want to give you an example by Excel. It is very easy and to do this by Excel. This is inputs x1, x2, and this is the output. If you look here, we have 5 rows here in this slide. We have 5 rows, but here I have many rows of numbers to generate this. I have used the term rand between for the first input. I have used the term rand between 1 and 5, and the same for x2. I have used the term rand between 1 and 5, and f is 2 in x1 plus x2. It means that W1 should be tuned as 2 and W2 is will be tuned as -1. I mean that lines we should receive 2 and -1. We can see the excuse me. Here is the error. I have calculated error. Error is calculated by, you can see the formula. Error is calculated by A2 in I don't know that you see this or not. This is the error is calculated by multiplying x1 in W1 plus x2 in W2 minus f. This is error. Okay, and delta 1 and delta 2 is the term that I want to add to W. In the Excel file, delta 1 and delta 2 is this is delta in my Excel file. Delta is the value that I want to add to the weight. Okay, delta 1 is a multiplication of input error and the fixed number alpha. This is alpha is 0.1. This is alpha. Alpha in my Excel file is 0.1. This minus, forget about this minus. This minus is used because I have calculated error incorrectly. I have used the minus to correct this because error should be calculated as f minus w in x1 plus w in x2. Okay. Again, I have x1, x2, f, w1, w2, error, delta 1, delta 2. This is w1 after changing by GS rule. I mean, this row, this column w1 is the summation of delta 1 and w1. If I add delta 1 to w1, I can say that this is w1 in the next step. And the same for w2. W2 for the next step is the summation of w2 and delta 2. This is the summation between delta 2 and W2. And in the next step, we just replace W1 and W2 by W1 plus 1 and W2 plus 1. This is just, this is just replacing W1 and W2 by the updated values. And we repeat this equation again, and by repeating this we can find W1 and W2, and we can find also error. If we have a look here, This is W2, and we see that W2 is -1 here. After enough calculating GST, we have received to -1. This is W2, and this is true for this for our data. And for W1, if you see, we have received to number, excuse me, we have received to number 2. Here you can see that W1 is going to modify it to number 2. And this is error, or error in different steps. We can see that, for example, by almost 150 duration, we have received to error 0. And error is 0 is example. This is the example that I've made for understand this data. It's very easy. We can repeat the GS algorithm times, and by its iteration, the value of weights will be found. If you want to ask a question, please ask me, and I'll describe this better if you think. But I need you to ask. How many of you are here? I see that you are 28. Please have a look on this file. Excuse me for connection, I don't know what's happening, but I want you to see this file. This is a description of GST using a very simple example. Please do this. You can understand if you try to try to understand, you will be able to understand this. This is not difficult at all. Just do this in do this in Excel, and you will find that how this is easy. And in the video that I sent to you, in this video, you could see the same subject, SGD, and it is described easily, and they have used, they have written the method by MATLAB. In order to be easier, in order to be easier, I have used Excel to be easier for you. Both the lecture, if I want to send it, I have to send it right now because I will forget to send. I recommend you to record courses by yourself because you can share this between you. Okay, I'll do this today exactly after the class. I promise to send this to you exactly after the class because I will forget if I give it for tomorrow. But what is the relation between this and neural network? What is the relation between the thing that I said to you and the neural network? Neural network is the feed-forward neural network, or the neural network that we know is exactly the thing that I said about this today. In neural we have a black box and we want to find what is here, what is in the black box, which function is here. And in neural network also, the first step is to guess a formula. For example, I can guess that this is, assume that we have 3 input, for example, and 1 output. Excuse me, I have a call, I have to answer. الو سلام حال شما خوبه من سر کلاسم فعلا کلاس اختصاصه واقعتش کلاس ما تا ساعت 8 ولی من حالا هر وقت تموم کردم بهتون احترام میدم سلامت باشید قربان شما خدا Okay, I was talking about neural network. In neural network also, I have to guess a function. For example, I can guess that f is I'm so sorry. I'm so sorry because this is Ramadan and our guards wants to go to iftar, so they all call me and say that when do you want to go? But no problem, we will finish our class at 7:30 in 30 minutes afternoon. At 7. Let me say it. I wanted to neural network and the tricks that and today's lecture. In neural network, also we have some input and output, and this is a black box, and we want to find what is in this box. Here also, at first we guess a function. For example, I say that f is g of wi in xi plus b. Let me write this again in the f is g of sigma of wi in xi. It means that w1 in x1 plus w2 in x2 plus w3 in x3 plus b. Here we have to find W1, W2, W3, and B. How do we find this? We can use the same method as I used right now. We can use with value for W1, W2, W3, and B, and we can update. We have the same formula for B. We can update the values of these parameters. We can update by GST, and we finally we find W1, W2, W3, and B. This equation that I have written here is the general form of neural network, a one-layer neural network. This is one layer, and this is a problem that I said solved is a special form of neural network with one neurons. And in my example, G was equal to identical function. It means that G of X is X. Let me write again. G of X was X in my example, but generally this is not true. G of X is not X. In general, it might not bias or be, but yes. But the solution is similar. If we have a more complex neural network, for example, if I have such a neural network, we have way more if I have such a neural network, we have many weights that we have many weights to calculate, and the formula will be more difficult. But the fundamental of here also we will calculate weights by formula similar to SGD. Formula similar to SGD. Make a conclusion. The SGD method to calculate the weight, calculate W's. in a neural network. We can write the code for SGD in MATLAB or in another language by ourselves, but because there is some details in the formula, and this is not very easy to write this correctly for big network. Mostly we use the ready function in programming language. For example, in MATLAB, we use I said to you, we can use new FF and then train. This is new FF gets a function for me, and train is to finding W's. Again, what is new FF? In new FF, I set a structure, or I can say that I guess a function. Here I guess a function as I guessed in my example, and in train I run GST formula or similar method to find W's. Train means finding W's. Okay, I see that you do not answer me at all, and I feel that I'm alone in this class. So this might be better to finish the course, and we will continue this on Monday. I'll send you the Excel file and the MATLAB file for training data, and I'm trying to download the recording right now before the guards come here. I sent you not PDF but PowerPoint of the my slides. Yes, I try to this to do this right now. I do this right now. Have a nice time. سیاحکم مقبول. نماز و روزه هاتون قبول باشه.